Movement competency is so central to so many aspects of life. The evidence is there that injury rates are higher for people who don't have that movement competency. The measurement of human movement is going to just explode.
Ciarán Simms, Chief Scientific Officer at KineMo, thank you very much for joining us on the podcast today.
Thanks for having me.
Tell me a little bit about your journey and tell me how you got into the world of startups. Was it on purpose?
Well, it was a journey. So I'm a biomechanical engineer. I've been a professor at Trinity College Dublin School of Engineering since 2001. My research interests are in injury biomechanics and human movement. I've done a lot of work tracking pedestrian collisions, cyclist collisions, understanding how the design of a vehicle changes the injury outcome. And then about 10 years ago, I started thinking about head injuries and concussion in sport. And I set up a collaboration with Leinster Rugby where we were trying to understand what type of tackles led to higher head injury rates. And we were doing a lot of video analysis where we were tracking players on the pitch, upper body tackles, lower body tackles, what was the head movement. And that involved a lot of manual analysis of videos. And we were thinking, this is very time consuming. Maybe we could automate this. I know there's a lot of developments in this area. I'm a mechanical engineer by background, but I knew that this was coming down the tracks. And then the physio at Leinster Rugby said, head injuries, they're clearly an important issue, but we have no means to quantify the movement of our athletes generally, except in a very small number of cases where we send them off to an expensive lab, which means that we're just judging everything by eye. And movement competency is so central to so many aspects of life, but sport in particular. And so that set us on the journey to think about how could we create something that was quick, but accurate enough to track human movement, to guide physios and coaches to make their decisions that they need to make for their athletes.
So I've got so many follow-up questions, but how did you get into this where you can look at those collisions and your mindset where we were talking off air about you both being cyclists and why we do it and we like it. But for a lot of people, when you mention collisions, crashes, they kind of turn away, and you're kind of all in. How did you mind that?
It's an interesting point. I mean, clearly there's a lot of human tragedy in the background there, but you have to develop mechanisms to separate that if you're going to from your daily work in the area. And having been introduced to the topic of human injuries and biomechanics as an undergraduate student, it just took my interest. I can't really explain why. And it just grew over time, and the potential to make a difference. And there are huge differences to be made. I mean, if you get struck on your way home by a car, the design of that vehicle could make a big difference to the outcome.
So you mean let's say one of the very safe cars, a Scandinavian very safe car company that we probably know versus maybe a car that's really not as well known. Would that make a difference? Because
Yes,
I always think about it from the perspective inside the car.
Oh, for both.
Versus
for both.
Yeah,
since 2000 and around 2005, the European Union tests the front of cars, and that's caused the difference between more risky and less risky vehicles to reduce somewhat. But if you get hit by a high-fronted, large SUV-style vehicle as a pedestrian, you're in big trouble. Whereas if you're hit by a passenger car, all else being equal, if the speeds are moderate, you have a good chance of surviving.
Yeah. So when we think about kind of collisions, and then you were kind of talking about kind of athlete movements and things like this, a lot of people kind of look at sports and actually thinking, okay, well, that sport's more chance of a collision than this sport over here. And from a parent's perspective, you're kind of thinking about that. I know I do. You're thinking about actually which sport can be doing it. And also from the athlete's perspective, how long they stay in that sport will probably be determined by collisions, athlete movements, and things like that as well. Do you find that when you were trying to create this product that you had a few different customers in mind when you kind of set out on the journey? That's the first question. And why did you feel like it was a journey to go on, that it actually was a problem that needed to be solved?
The journey started with trying to track athletes on a pitch with videos and track the collision forces. That was our research plan 5 years ago. That's technically very difficult to do. And
why?
Because there's lots of players on the pitch. The camera positions are tricky to manage. So there's occlusion and other aspects going on. But then also the imperative to solve a problem was impressed on us in the discussions with the end users, who said, yes, the on-pitch stuff is important, but if you can track movements in training and in exercise development, that will actually solve a big headache for us. And so it kind of pivoted my approach. It's like, okay, I really like to figure out what's happening in collisions on a pitch, but if I can solve this problem for these people, that will lead us to the technology that can allow me then put it onto the pitch in the future.
Yeah.
And so that's kind of how we got to where we are now.
And so you've got a kind of a multidisciplinary team.
Yes.
Where people kind of wearing different types of hats. Tell us a little bit about the kind of the team of the dynamic that you've got.
Yeah, so I'm a biomechanical engineer by background. We have within the technical team, we've got experts in computer vision and AI. We've got a business manager, Leo Payton, who has a finance background. And then we've got a team of subject matter expert advisors, coaches and physios. Des Ryan and Lara Coyne and Gareth Farrell in particular. And we're growing that because really to make a product that at the end of the day is an app that people use requires expertise across a wide range of areas. And sorry, I didn't mention there that our Chief Technical Officer is the software architect, David Jones. And that's been a recent development for us because now we've moved from the back-end technology of how to do the models to how do we actually implement this in an app that users can use.
Yeah. So when you're going to use this app, how do you kind of see this playing out between who's the customer? Who are your customers?
Okay. So we have our main customers are coaches and physios in elite sports teams. So we've got trials at the moment with a number of national governing bodies for cricket, for rugby. We've got trials going on with GAA. We've got trials going on with some international soccer clubs. And it is the coaches and the physios at these clubs that are picking individual teams that they want to track for baseline or for rehabilitation.
And so how does the underlying tech work? Now downstairs, we had a little bit of a kind of a demo, and the goal is to weave in a demo into this podcast, video podcast, so we can kind of talk about that.
Yes.
But I was doing the squat, and I was kind of showing my form.
Yes.
And as you kind of politely said, you know, your form is off, right? And there was probably a few different factors for that. I can only imagine if I had an injury, me trying to do my bad squat as it is, what that would look like. Talk me through what I would be seeing if I was that physio or I was that coach.
Okay, so when an athlete completes an exercise, at the moment that is assessed by the coach or by the physio, and they are subject matter experts, and they can do an excellent qualitative assessment. The problem for them is that they have dozens of athletes on their books, and they're tracking these athletes week in, week out, and it's very difficult for them to remember this week how the athlete moved last week. And it's extremely difficult for them to go from a subjective rating to an objective one where they say that joint angle is 55 degrees today and last week it was 60 degrees or whatever it is that they're interested in. And so our technology comes in by setting up a camera at a particular angle to take a video of the event. And that's the only measurement that we take. And that video is uploaded into the cloud and then appears in the analysis app. And from that video, we use our computer vision and our AI models to extract the joint positions and then the joint angles in three-dimensional space and present them back to the coach or physio as a quantified measurement. And so to bring that back to you, when you did your squat, one of the things, I am not the expert for assessing movement. I'm helping to do the measurements, but I could see that you were tilting your torso forward quite a lot. And so we could measure directly that torso angle and feed it back to you and say, look, Mark, you're compensating for a lack of mobility in your lower limbs by tilting forward at the hips. We need to work on this, and probably you need to go off and do some mobility exercises in the ankles or the knees or the hips, or maybe strengthen some core muscles in the lower back to allow you to get deeper.
Yeah, because actually for everyday people, not just athletes, squat is actually a very, very important exercise to be able to do well.
Yes, it seems that when you talk to movement experts, the squat is kind of the go-to exercise. And although there are dozens and dozens of different exercises, what I've kind of been hearing recently is that you can sort of tell from a small number of movements of a person what their general movement competency is like. And the squat is a particularly good one.
Tell us a little bit about how you're using AI within the product?
Okay, so we take a video. The video consists of still frames, and the first step is what's called 2D key point estimation. That's an AI model that extracts from each image frame the position of the shoulder joints, hip joints, and so on. That's in pixel coordinates in the image frame. And then from there, we train a different AI model to learn what the 3D positions of those joint coordinates would be. And from there, we calculate the joint angles. So there's AI in the extraction of the 2D key points. There's AI in the uplift from 2D key points to 3D positions of key points, and there will be in the future a lot more AI as we manage our very large data set of that comes from our users, and we can extract value from that as well.
Ciarán, can you talk me through the demo, what's happening with the athlete in their squat without the injury and then with an injury, or whatever version you want to show first?
Yeah, sure. So we had an athlete in the sports centre in Trinity, a rugby player, very high-performing athlete, and he first came in and he did a squat, a baseline squat for us, and in that baseline squat, if I press play on it, I can see that looking at it, first of all, he's getting a very deep squat angle. He has a good coordination between his shin and his torso, and he's not displaying any inward or outward movement of his knees, no knee valgus to be concerned about. So that's a very good movement at a broad level, and it's nice and symmetric. We then got him to perform another squat, which we asked him to simulate how he might move if he had a knee injury. So it wasn't a genuine injury, it was a simulated injury in this case, but he moved quite differently in it. And if we upload that recording into the system, then it plays the two of them side by side. And in the second or injured squat, because he's simulating having a knee injury, he's not able to produce the same level of knee flexion. So the knee angle is greatly reduced. And he's compensating for that, as a lot of people do, by tilting forward at the hips, which means that his torso angle is increased substantially. And if you look at the time history of the knee flexion curves for the uninjured versus the injured case, you can see the much higher knee angles for the uninjured case. And conversely, if you look at the trunk angle for the injured case, you see much higher trunk angles. And in our experience of dealing with coaches and physios, when they have recorded this in their actual clients, they find it very useful to have quantified information. They can see the general gist of that by eye themselves, but this keeps a track of it and allows them to quantify and say to the athlete or patient, look, this is where you are now, this is where you want to get to, and it gives them a goal to move towards.
And it's so good because it's quantifiable. You can only imagine what goes through an athlete's head when they're not on the playing field and they can't even train with their team. It allows them to work towards a metric, measurable, and then it kind of that peace of mind as you're kind of moving forward. And then there's so much insight I'm guessing you could probably get from rehab to show, well, statistically, if you do more of this, we've shown that it could be faster recovery or
I think we will see that. It's going to take some time for the data to demonstrate that, but there is evidence to show that improved movement patterns reduce injury outcomes. I mean, it makes sense. And I've just shown you a small subset of the kind of metrics that one can look at. If you want to drill into something in more detail, the app allows you to go into other metrics and do that.
So people from the outside will probably be fixated about AI, but for a lot of people, they're starting to really understand is the data and how challenging it is to get access to data. How have you found that journey?
So it's been a long one. There are quite a lot of open source models. Those open source models are trained on data sets that don't relate to the particular kinds of movements that are of interest to us. And what we learned is that although some of the open source tools are in principle powerful, they don't actually translate very well into meaningful information at a subject specific level. And so we had to set up a lot of experiments of our own where we got participants in, we put markers on them, we collect their movement using a ground truth tool, marker-based motion capture tool called Vicon, and then we train our models off that. And absolutely, the data is crucial.
Yeah, because trying to get access to the right data where some people, they don't want to hand it over, then some of it's inaccessible, then it's dirty data, it's not accurate data, like the list goes on. I can only imagine the challenge to do that. But once you have that access to the data, you're kind of building that moat because you've had to work so hard to get it. Now that you've got it, it's a very, very strong position to go from.
Yes, the journey seems like a long one, but if you kind of look back in sort of 2-year intervals, where we were 2 years ago, 4 years ago was very different to where we are now. And as you say, our bank of movements for which we have captured data is growing and will continue to grow. It's one of our areas for growth.
So let's say I'm a physio or I'm a coach and I'm spotting the athlete's squat or exercise or mobility. Do you see this as a way that you'll be able to get that athlete back on the straight and narrow sooner, quicker, back on the playing field quicker because you've been able to use this as a metric rather than I think it looks okay, my gut feels, where you can actually show those kind of clear measurements, how they've kind of improved?
Yes, I do think it will make a substantial difference because a lot of athletes are very motivated, but they need something to work towards. And if you can say, look, this is where you are now, this is where you want to get to.
It's quantifiable.
There's a quote from a Yeats poem that I love. It's called Under Ben Bulben, and in it is the line, it's nothing to do with sports mechanics, but it's a line, measurement began our might. And I think that if you can measure something, then you can start to put in place an intervention and assess whether it's made a difference or not.
Yeah. And I can only imagine when you're an athlete, all you can see is you want to get you want to get back on the pitch. You want to get your squad number back. You want to be around the team. So you're moving towards some type of metric where you feel like, okay, yes, I am getting closer, or I'm not, or you've got those different areas. So from a mindset perspective, from a mental health perspective, it's really, really important.
We spoke to one international player who said to us, a rugby player, if I knew that I was moving the way I moved before I was injured, that would give me really good peace of mind. At the moment, he had no means to measure that. So I really think that the capacity to measure will drive a lot of change.
Because unlike like Tiger Woods, who's got like 7 coaches, people looking at his swing and so many different areas, people aren't walking around analysing like that. So to have that type of measurement is so important because I'm guessing you can also benchmark against your colleagues or benchmark against other players for different squads in terms of how flexible they are or what the average rating should be, for example.
So we will have different thresholds for different cohorts of people. And we also envisage a kind of a league table competition set up within teams where you can have the kind of leaderboard for movement competency in the same way as you might have it for sprint distances or whatever.
But wouldn't that be just amazing for people in general life as well? To have that kind of movement board to say, well, actually, you're this age, or you should be kind of aiming to get towards this, and this is your kind of a standard for a good life. That's just something that occurred to me.
I do some coaching of a teenage GAA team, and I can see these are 14-year-old girls. Some of them are excellent athletes, but some of them definitely need to improve their movement competency. And the evidence is there that injury rates are higher for people who don't have that movement competency. So it will make a difference.
Yeah. I know this isn't an area that you necessarily focus on, but I can also think for people who are maybe dyspraxic, where maybe their kind of movement is more challenging, to actually have extra additional work on that would probably kind of get them to a higher level.
Yes, there are many applications outside of direct sport. And in fact, we're working with the Institute of Healthier Living in Abu Dhabi, and they're doing a movement screening of the general population, as part of which we're not only doing standard sporting exercise movements, but also activities of daily living, sit to stand and arm raises and that sort of thing.
Where do you see this playing out in the years to come? Because everyone is getting so involved in sport, the interests and desires to get the best players on the pitch. There's so much interest in that, and we're trying to live healthier lives. We're more conscious, I think, what we're putting into our bodies now. How do you see this kind of evolving over the years to come?
It's a good question. I'm not great at the crystal ball, but I think that the measurement of human movement is going to just explode. For me personally, the motivation to improve the movement patterns of a large number of people who currently have poor movement is more of a motivator than to get from 99 percentile movement of a top-end athlete to 95.5, if you know what I mean. So it's the kind of making a difference at a societal level would really motivate me in the terms of tracking of movements.
Yeah. And if you were to offer your younger self advice before starting on this journey, anything you do differently, or what would be kind of key takeaways?
Well, you have to be patient. Everything takes longer than you think it's going to take. You have to accept the kind of highs and lows. It is quite a roller coaster experience. You have to just keep putting one foot in front of the other, believing that it'll keep going, and then savor the wins when they come. It's been a journey of trying to track, get initial investment from Enterprise Ireland. They supported us, but it took us a few runs, and gaining clients, and then making sure that you've got sufficient resources to do what you need to do. There's challenges on the way, but well, it's worth it. Just keep going.
Ciarán Simms, Chief Scientific Officer, KineMo, thank you very much for your time today.
Thank you, Mark.
We're passionate about collaboration and sharing the incredible stories behind every AI journey. That's why we're always looking for guests to join our in-person AI Ireland podcast experience. If you're working on innovative AI projects or have a story that can inspire others, we want to hear from you. This is your chance to share your insights, experiences, and ideas with a really vibrant community that's as excited about AI as you are. So if you're ready to be part of this conversation and help shape the future of AI in Ireland, please get in touch today. We can't wait to collaborate with you.